homomorphism for which U is the kernel. So that follows easily from the similar group theoretic result. We are just going to mention that here. So that is the first result of this section. If U is an ideal of a ring R, then quotient ring R by U is a homomorphic image of R, and U is the kernel of the homomorphism. Okay, so its proof follows a similar pattern as the group theoretic results proof. And just like that, there is one more thing in group theory, the correspondence theorem, and that also can be that also has an analog for rings, which is our theorem 341, and it goes like this: let R and R prime be rings, and let phi from R to R prime be an onto homomorphism. It has to be a surjective or onto homomorphism with kernel U. Okay, then the first thing is this. Then then R by U is isomorphic to R prime. So that is the first isomorphism theorem. And there is more. R by U is isomorphic to R prime. There exists a one-to-one correspondence between the ideals of R prime and the ideals of R containing U. If you take the collection of all ideals of this second ring R prime, and if you take the collection of all ideals in R such that each one of them contains the ideal U, then these two sets, there is a one-to-one correspondence between them. And how do we substantiate this correspondence? It's given like this. And This correspondence associates an ideal W prime of R prime with the ideal W of R, which is defined like this. It's the set of all elements A in R which are mapped onto W prime. Ideal W prime of R containing U. With these ideals, W and W prime, R by W is isomorphic to R prime by W prime. So this is the statement in its entirety. It has many, it has the first isomorphism theorem corresponding to the one in group theory. It also has the correspondence theorem. The first isomorphism, okay, so first of all we are given two rings and there is an onto homomorphism from one ring onto the other and its kernel is given U. Then R by U is isomorphic to the image R prime. So what does this tell you? This tells you that all homomorphic images of rings can be obtained by considering only ideals. We don't have to go outside to other rings. The other rings, all the homomorphic images can be generated by considering ideals of the original ring. That's what this one says. What the other one says is this. Here you have R. Here you have R prime. Now in R prime we have ideals, right? Many ideals are there. In R also we have ideals, but there is a onto homomorphism phi from R onto R prime, whose kernel is U. Now if we collect all the ideals in R prime and if we collect all the ideals in R such that they contain U, then these two collections are they have the same cardinality. There is a one-to-one function, and according to that function, if we have a W prime an ideal here, then we can consider this ideal, which is actually nothing but the inverse image of W prime under this mapping phi. This turns out to be an ideal of R. If W prime is an ideal of R prime, this turns out to be an ideal of R that contains U. And this substantiates the one-to-one correspondence. This is a one-to-one mapping. And with these two ideals, if one forms the quotient ring, this, and on the other hand one forms this quotient ring, they can be formed because this is an ideal of R and this is an ideal of R prime. These two are isomorphic. Okay, so with this section ends. Section ends means the text part of this section ends. After this we have the exercises. So next are the exercises.